All right, so welcome to the fuzzing panel. I'm going to quickly allow, since we only have 20 minutes total again, probably, I'm going to allow 60 seconds or less, let's just say 30 seconds, for each of these distinguished gentlemen to introduce themselves and say something quick about why you should listen to them and not heckle them. Let's start with you.
I say you go ahead and heckle, man. It's Vegas. Yeah. So my name is Mike Eddington, and I'm the author of the Peach Fuzzing Framework. It's one of the most widely used open source fuzzing frameworks around. And I've been doing computer security for the past 10 plus years in professional capacity, focused on application security, embedded device work, kernel, user land, protocols, the full gamut.
Wait, one trick question. What is your favorite zombie movie and why?
Zombie World, because it's the only one I like. Or maybe it was Zombie Land. What was the Woody?
You don't even know.
I don't even know, man.
Zombie Land.
There is a Zombie World, though, so.
Okay, and since he's been preparing for it, let's skip him and go straight to Charlie Miller. Charlie, I have a question for you. Do applications just bow down and give you their buffer overflows, or do you actually have to work anymore?
I was going to answer about zombie movies.
Okay.
Actually, they're too scary. I don't watch them.
Right. So 30 seconds on who you are and why we should listen to you.
Let's see. So, Charlie Miller, I've been doing fuzzing for a while. I found the first bug, or wrote the first exploit for iPhone and Android when it came out. I've won CodenomiCON for the last 4 years. I give lots of talks. I broke like every application you can imagine with 5 lines of Python.
Yeah. And he's very humble. So seriously, what's your favorite zombie movie?
I seriously don't watch zombie movies. I don't know.
Charlie, it's Scooby-Doo and the search for zombie eyes.
This is my wife. That particular episode of Scooby-Doo was too scary. I didn't watch it.
Okay, we can go to Jared next.
I'm Jared DeMott. I've been in the industry for a decade or more and done a lot of fuzzing. Helped out with the fuzzing book, given talks at Black Hat and DEFCON, did a training here at Black Hat just a couple days ago, and just have general insight into different frameworks. Have used all kinds of different fuzzing tools and have been around. So hopefully I can have some kind of good info. As far as zombie movies, I'm with Charlie on that. Scooby-Doo is almost over my head, so I got nothing on the zombies.
Wow, you get this now. Okay. Ari?
So my name is Ari Takanen, and I'm one of the founders from CodenomiCON, but I think in this panel I'm kind of like the opponent here because we have lots of open source tools, so I can try to defend the commercial tools, not only ours but others as well. So let's see how it goes.
It's taking the adversarial tone, okay? Okay, so we would like to ask, we have some sample questions that someone provided that I'm probably going to ignore. I'd much rather hear from the audience what you'd like to know from the group. I will start off with a few. Okay, we'll throw one to Charlie, but this is your 3-minute or less warning to come up with your own. Eric, especially. I'm going to ask, so Charlie, you read a lot of custom buzzers. So, how much time do you actually take making the buzzer versus running it versus digesting and interpreting the results? If you had a pie chart.
Okay, let's see. So, first let me say, like, this panel is really awesome. Like, pretty much all the like really great fuzzy type people are here, so you should be very lucky that it's a really cool panel. So anyway, so let me just think. So most of the fuzzing I've done that I've actually, usually I just fuzz, I find a bug, I stop. So it's not like real thorough. So the one time I did the real thorough fuzzing was with the 5 lines of Python thing. So it took about 10 seconds to write the 5 lines, but to write the actual fuzzer that was a little smarter than that and actually did something, probably took me, I don't know, a few days, a week maybe. And then to run it, I ran it for 2 weeks on each product. So, times the number of products. And then, for me, the biggest time is analyzing it. So, one of the bad things is I write these really simple, stupid fuzzers. So that's easy. But then everyone else does that too, so usually the bugs I find are sort of the like really hard to exploit bugs. Like I never find the EIP equals 41, 41, 41 bugs. I find the ones that it's like, you know, it did this, it caused 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 this. So, so almost all my time is, you know, I have all these crashes, I have to figure out which ones are the easy to exploit ones, which ones are exploitable in the first place, and, you know, why does, and then at the end, this crash looks good, but what the hell did it do to the program? Like, why does it crash? You know, and can I control it? That sort of stuff. So most of my time is on that. And that's, I think, a consequence of going for the low-hanging fruit, which is sort of my profession.
And I have a follow-up question.
Have you found an automated way to determine exploitability of these bugs?
So, that's a great question. Right, so, you know, Bang Exploitable tries to do that. It doesn't do.
We're recording this, so I'm going to repeat the question.
Okay, go. You want to repeat it?
Is there an automated way to verify exploitability?
So Bang Exploitable tries to do that. It doesn't do that great a job. You know, Crash Tracker is the OS X version. So my Black Hat talk last year was basically my try at doing that, and it didn't do that great. No one really knows how to do that. This is the really labor-intensive part of things. There's not a good way to go from a crash to, you know, a root cause, or to go to you know, an exploit. So that's the one part that really no one knows how to do in automated fashion. You know, you can do your best, and Bang Exploit is the first step, but it doesn't do that great.
Maybe you are just selecting too hard targets. So if you would take any embedded devices or anything, it would probably be much easier to exploit.
I mean, you know, sometimes, I mean, it's, you know, some bugs are better than others, right? So like if you look at Comics' bug for jailbreaking, this bug was awesome. It allowed you to corrupt stuff, it allowed you to read things, it allowed you to write things. It was, you know, the perfect bug. And, you know, like I said, most of the bugs I find are, you know, it read one byte too far, and then it used that byte as, you know, an index into a write, which was, you know, only restricted to 5 characters, and, you know, it's all these crappy bugs that are, you know, incredibly hard to exploit. So a lot of it comes down to the bug, and, you know, some fuzzers are better, I think, in finding these better bugs than others.
So I might add on to that, you know, really that, I totally agree, you know, if you want to actually go and write exploits, based on the bugs you're finding, the biggest time you're going to be spending will be analyzing your crashes to determine if they're exploitable, let alone then going and writing the exploit. Luckily though, for the majority of people probably doing fuzzing, you don't have to get to an exploit. Like all you really cared about is you got 1, a crash, and 2, maybe you got some basic risk analysis done on it. So in that lane, I do think that, you know, frameworks like Bang Exploitable, as much as they don't do a perfect job or anywhere near a perfect job, if they can get you just a little iota closer and allow your tester to at least, you know, say, hey, this isn't a duplicate, and hey, you know, at least Microsoft thinks it might be exploitable on some, you know, universal, in some constellational configuration. At least that gets you farther along, you know, the path, and that means you can at least prioritize the things you're going to look at, and you know, at least for the average user, especially the person doing defensive, say fuzzing for the corporation SDL, I think you get a good leg up on that.
I wouldn't mind adding a little on that too. So one of the things I didn't mention is that my company is actually writing like a distributed fuzzer, a cloud fuzzer, and as part of that, that's definitely the biggest problem. So you run this thing and you get tons of crashes, you know, tens of thousands or hundreds of thousands or whatever, and we're using Bang Exploitable as part of that process to, like, you know, try to sort it out, so then you end up with, like, you know, only 10% of those or 50% of those or whatever in exploitable, or you end up with like big chunks and pieces of, like, you know, these 10,000 say they're exploitable, these 50,000 say they're unknown or whatever. And unfortunately, it's still really not good enough in terms of prioritization, depending on what you're trying to do. So from a developer standpoint, it's like, okay, maybe that's good enough. If you're more on the offensive side and you're trying to actually figure out, okay, we want to figure out which one of these with most likelihood can we actually write an exploit for, then it's that's a ripe area for research. I think there's probably going to be more coming out from researchers in that area. I've been doing a little bit of research in that area as well. In academic computer science, they call that fault localization, basically. It's kind of the term for trying to figure out where exactly the fault happened and stuff, so some of the stuff.
And then another consequence of my, like, really stupid fuzzer compared to something like Peach or CodenomiCON is that I have no idea what caused the bug, but at least if you wrote a Peach script or, you know, CodenomiCON or whatever, you could use, you know, you could say, oh, this was the one field that changed, and it was a link field in this structure or something. And you're like, hey, that sounds good. Where if it was like, this is, you know, the bit in a red, green, blue field. You're like, well, that sounds kind of sucky, right? And so
you guys don't only attack Windows, so what are some other, like Linux, for example? We don't have any routers that run Windows, so what are some tools that you would use on Linux that would find these type of things?
Peach runs on all platforms.
No, not finding the bugs, but to find
Oh, you do the analysis.
exploitability analysis.
I mean, IDA runs great on Linux and OS X now, so that gets you a leg up. And then it really comes down to, your platform of choice. I mean, I think, I spend a lot of time occasionally IDA with embedded systems, and it supports most of those processors, so you get your crash done, or loading information off, loading the IDA, do some reverse engineering. I guess it really depends on, do you have full access to the source code, and you're doing defensive work as the vendor, or are you doing the analysis as someone who's evaluating purchase, or doing the offensive work? Will really affect your approach.
So if you look at that from our perspective, then if you start debunking bugs and looking at if they are exploitable on like all the platforms we need to support, ranging from mobile phones to embedded operating systems and all that, that's mission impossible immediately. But when you do model-based testing, the actual anomaly and the place where you're putting that indicates almost immediately whether it's a buffer overflow, whether it's just a boundary value, or off by one, or whatever. So the bug category is actually easy to determine from the input that actually causes the crash. So you don't necessarily need to use anything on the target itself, but actually learn from the inputs that you are generating what is the likely cause, what is the actual mistake in the code that is most likely to cause that problem. So that's easy to then just put those bugs in the buckets and say that these are most likely to exploit, and these are harder, this needs Charlie Miller to exploit, and so on.
And I think that's what you were saying, right, Charlie? That's basically the difference between mutation fuzzing and smart fuzzing, is that with smart fuzzing it may be harder or cost more or whatever, but it's easier to analyze the crashes after the fact.
right, you at least have some knowledge about what the fault you injected was, as opposed to just some random thing.
Yeah, you gave it this huge blob and you got this crash. Good luck with that.
Right, which is my life.
Yeah.
So,
Yeah, but in the bugs you need both approaches.
Yeah.
And
So-
you need to identify which ones are duplicated, which are not. Otherwise you lose a lot of time.
So I'd like to triangulate a few of these questions and try to be efficient. So you've all been doing fuzzing for quite some time, either through for pay or open source or self-written spontaneous combustion types. Do you find your job is getting easier, harder, or about the same?
I would actually say, I guess I'll take that one. We actually did a talk at CanSec this year and Fuzz 10 years worth of Office, Open Office. It was DOC, XLS, PPT. And it was actually very interesting. One of the things you can immediately do is you can identify the exact year that Microsoft implemented the SDL. Like seriously, the bug count would go with 100,000 iterations, which is a very low iteration count. In 2003, we have like something like 126 unique interesting crashes, and that goes down to like 16 in 2007. And then you get this, and then it continues to go down to 2010. So I think that was pretty telling. I mean, I think initially with fuzzing, it was kind of like shooting fish in a barrel, and sometimes it still is. But as more and more people do fuzzing, and as more and more people do SDLs, we do start getting to the point where it is harder and harder to find bugs. Even with people that, some of the products that have been picked on recently, like Adobe products, even with them, with the current revs, the number of iterations it takes to find any unique bugs in Acrobat has gone way up from what it used to be. I mean, it used to be you just ran your fuzzer, it was like crash, 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 crash. And now you can average maybe like 50 to 100,000 iterations per, unique crash, or at least for your first crash. And so I think that shows, some pretty good trends in the industry. I certainly don't think we're going backwards. I think we're making forward progress. Now, obviously, as our fuzzing technology can evolve, it opens up new paths. The more, we're in our infancy. And so it seems like every year, Charlie's going to be talking, he's like, hey, what about code coverage for template selections? Anyone thought of that? And all of a sudden, bug counts go through the roof. But those are kind of like, almost like, those are tool advances. Isn't that our software is declining. So I think eventually, things start, you see downward trends for the most part. That is what I've seen. I don't know if you guys want to comment.
We need some disagreement on this.
Yeah, someone disagree. Charlie, Come on, disagree.
So if I look at it from my background, so in the very early times, I was working at the University of Oulu, and we did something like SNMP, fuzzing, ASN1 box, and all that. And still, if you use a commercial SNMP tool, it will still break pretty much everything except maybe Cisco. But pretty much any network device you take out there is not using fuzzing yet. It's equally easy to break that than it was back in 2001. It's even easier because tools are smarter. But I think that's the biggest problem, is that it's only a small fraction of the vendors who are actually using any kind of fuzzing. So the companies here are not like representing all the industry of network devices or home appliances or whatever. Most of the products are really, really bad quality, unless they have been fuzz tested, and then it becomes harder and harder. So we have customers saying to us that, why can't I break this product with your fuzzer? But it's just because that vendor is doing a better job than the other. So, but it's still equally easy as long as you pick the easy targets.
It's always obvious when you fuzz something that's never been fuzzed. You're like, this is clearly
Yeah, I was actually going to add on to that too. I mean, because you're talking about how as tools get better with cloud fuzzers, and it's getting, maybe it used to take 100,000 iterations to get a bug in Office, and now it's like 1 million iterations, or whatever the difference is. But if you take that tool, how it's advanced, and all of a sudden some new little startup company pops up and they've never fuzzed, and you hit it with this advanced fuzzer, you're just going to destroy that code base.
Well, that's what it is. Nowadays it's finding that company who's never done SDL and who's been lucky enough to get away with not having a huge, not being seen by everyone. But I think that rapidly is starting to change too. I think as a security consultant, it used to be you had to really twist arms to get in the door, and I think now even when now people understand. Now it's more a question of how much budget do we have and the right company to come in. But I don't think there's anyone that nowadays that doesn't realize they need to do it. They should know that they've hidden away from us and haven't been found yet. Which I think you can call improvement from times gone past.
So let's pivot this. Outside of the DEFCON Black Hat community, we have aggressive, cheap, cash-strapped, CapEx-strapped business leaders who are adopting cloud services and soap, for goodness sake, and just putting everything in non-data centers, temporary, transient, short time to live applications and servers on something like Amazon's AWS. How does cloud computing either benefit application ruggedness or threaten application ruggedness? And I'll direct this first to Jared, because one of the problems with fuzzing in the past has been time and space. Like, how can we do enough fuzzing quickly enough? And with things like spinning up lots and lots of temporary servers on Amazon, is that an asymmetric benefit to an attacker, or is it equally beneficial to the defender?
That was a really long question.
Huge question.
I'm sorry.
Sections left.
Let me simplify it. How does cloud computing change the problem space for fuzzing?
I think just like what we were saying, I mean, it allows the ball to keep moving forward against complex products. So where before, if you just have one machine and it's going to take you 300 days to find a bug, it's just not really worth it. It's too hard, it's too much time. But if you have 300 machines, it just takes 1 day again.
Yes.
So you don't use the
At the
cloud,
same
though,
cost.
right?
I mean, you can imagine.
Have your own cloud.
Yeah.
Well, yeah, we're using a private cloud, but it's the same difference, I think.
Well, not exactly. So I wrote a fuzzer once for the real cloud, the Amazon cloud, and then I did once I took it 2 weeks to write it, and then I did the math, and I was like, wow, that's really expensive. I can't afford to run that fuzzer.
Well, but it's interesting though, if you consider the cost for owning one box in a corporation for a year, multiply that by the number of boxes you need to make, your shipping deadline, compare that to ECW, it turns out the cost of ownership is pretty similar. And if you take into the fact you can do an entire SDL, quote unquote SDL fuzz run in like 1 day or 2 days, go back, fix bugs, and run it again, and do that way before the end of your ship date, like that amount of flexibility is just massive for a corporation. It's just massive. So I think there's a huge win with being able to go, like, spin up 1,000 boxes in the cloud or 100 boxes. And I think we're seeing that with the fuzzers too. Like Jared is doing cloud fuzzing. I have a managed fuzzing service. CodenomiCON, I think, is spinning up a managed fuzzing service. Like, just the fact that almost everyone sitting in this row has already thought about that and is doing it shows you that that's the direction we're going, and that makes sense.
I think, if I may add, running a fuzzer in a cloud or a dedicated computer is really a matter of choice. So for example, just about a year ago, we were doing some fuzzer performance metrics, and you can get really cheap hardware nowadays. You can get like 30, 40, 60 cores for less than $5,000 or something like that. So of course it's a choice whether you actually want to invest in the hardware, and then you can easily get into like tens of thousands of test cases per second, which is rather fast. Compared to not doing any hardware investments and running similar kind of speed on a cloud-based service. So you can get good performance with both options, but it's more like which one fits your needs better.
Okay, Charlie's very quiet. I'm going to switch slightly. How much time do we have? Plenty. Wow. Okay. So, I mentioned earlier that when you did a market survey on spending, it's actually very, very, very little. And we are in a very, cash-strapped economy. So I don't want to get in an open source, closed source kind of fight. But so for your open source Peach, have you seen an uptick based? Do you see any correlation between the adoption of free or open source Peach over because of the economic situation?
No. I think that one of the misnomers with open source is always thinking that open source means cheap. And certainly it's one of the things I face with Peach is a lot of people will say, hey, Peach is open source, why the heck would I ever pay for CodenomiCON? Well, the reality is nothing is free, right? There's always a but. And the big but with Peach is, you get the framework, but you don't get the definition of the protocol. And honestly, for anyone who sat down and tried to write a definition for a protocol, even like a Wireshark dissector, that takes a lot of time, detail, and a certain skill set. So I mean, I'll be very honest. If I walk into a non-technical company and they want to fuzz a new protocol, I tell them to go call CodenomiCON or talk to a commercial vendor, because I just don't think that they're going to get. It's going to cost them so much to train, to write the implementation, and to really do it right. They may not even have that skill set. Now, I mean, where Peach really shines, and a lot of these open source fuzzers shine, is when you do have to write the custom model anyways, like here at the Intel, the Microsoft, where you have custom protocols, you're tweaking protocols, you have your in-house talent can actually handle running command line, fuzzer, installing maybe Python, maybe they have some actual talent. That's where it can really shine, because then you own the IP you build up, and it's something where it's really a different space. Like, if you have a custom protocol, if you want to use a commercial vendor, you have to convince them to write a protocol for them. So either way you look, there's some sort of time investment.
Well, CodenomiCON has a PCAP fuzzer now, so.
Yep, and Peach does have, for Peach we do have fuzzy proxy that uses Wireshark to dissect. So for a lot of well-known protocols, you're good to go. It really ends up being what the company's outlook is and what they can handle in terms of the technology.
I've seen in many of our customers even that you have maybe a handful of Peach users probably at every company almost we work at. Then you have a couple of 10 maybe users that use the actual fuzzers created with Peach. But then the biggest problem is actually the rest of the people who cannot even use that. So they need easy to use, automated tools that fit into a specific process. And that's where commercial products will typically come into play. So quite often there is a Peach fuzzer that needs to be replaced just for the usability reasons and coverage reasons or something else. And quite often I've seen also what happens is that just a Peach expert at some company just decides to change to some other company, and they are left with any kind of open source mess to work with. So that's often a place for commercial fuzzers as well.
Now, of course, the nice thing is, as people continue to evolve tools, thankfully on the open source side, every version gets a little bit nicer and easier to use. So, but still it comes down to, a lot of times for the customer, it makes the most sense to go commercial.
So, one of the things that Wendy's report revealed is that we speaking of low spending, is we talked to lots of CISOs, and 9 out of 10 of the projects for their very first AppSec project failed. The first project was their last project. What kind of guidance would you give on where in the maturity cycle you should start fuzzing? Is it step 1? Is it step 4? Like, how do you make sure that their first foray into your tools isn't their last? The signal to noise problem.
Yeah. I think that's a great question. I've come to a lot of companies and tried to do fuzzing in various places in the SDL. For people who are familiar with the SDL, if you would think about the Microsoft SDL and its phases, I tell people to go for verification phase first. Now, verification phase is a fairly late phase. That's where you're going to have your third-party validation. But it's also the safest place to do it. And the reason I point them to that first is that's after you've gone through your testing phases. You have a stable product for the most part. Things aren't changing out from underneath you at nearly the rate they would be earlier on. And you have the most likelihood of getting some success. And the worst case scenario you have is you find too many bugs to fix by ship date, but I'd still kind of call that successful. And then once you've done that, you're going to have the internal knowledge to determine when you should keep doing it. And I usually tell teams, once you've got the fuzzer going, never stop running it. You may pick a way you may pick an end point for shipping your product, but once you've shipped, hardware is cheap, just keep running it. If that fuzzer finds even 1 bug a month, or 2 months, or 6 months, it's more than paying for itself right there.
Just to add something, I think the most biggest nightmare projects we've had are mostly to do with agile processes. So immediately when you have something executable in the agile cycles, you start fuzzing, of course. Because if you already have that communication interface that you're interested in fuzzing, and if you already have as a tool available, then start fuzzing immediately. Because earlier you catch those problems, the better it is. And it's still the same as in the waterfall model. In Agile, you have the testing phase in almost every cycle as well. So that's where fuzzing comes in. So as soon as you have something executable, you can start fuzzing already. And in most of the products, you actually have modular, different protocol stacks that you can already start fuzzing without even having the actual application logic on top of it. So depending on the team that you work on, you can start fuzzing earlier. You don't have to wait for the complete product to start testing it. You can start testing those subcomponents already.
So this is a great example where I usually use Peach on custom protocols really differs from buying the commercial product, which is doing more known existing protocols. And for that, I completely agree. If you're doing a known existing protocol with a commercial fuzzer, you're not going to run into a lot of pitfalls you will trying to develop your custom custom protocol fuzzer. Because the big issues you're running when you fuzz too early with that is the protocol shifting. The bugs you're finding are the bugs you're going to find in your first test run, and you're really start getting self-defeated. You're not finding the good bugs. You're constantly having to rewrite your fuzzer. But certainly, if you're going to be doing a well-known protocol and you have a commercial fuzzer, yeah, there's no reason not to start doing it immediately. You might as well find difficult bugs early.
And actually, we don't only do public protocols. I think we probably have more proprietary interface fuzzers than public protocol fuzzers. So it's not a choice also there. You can choose to build the fuzzer yourself, or you can ask for someone else to build the fuzzer for you. So that's the choice actually.
Okay, I took a couple of questions from people in the cocktail hour, so I will shift to them next. We care about the people. So, Charlie, when you're not blowing up Macintosh batteries, you're winning CodenomiCON contests. Which fuzzers did you use to win the last 4 CodenomiCONs?
That's a great question. Let's see. So 4 years ago, I won with a bug in the way they parse regular expressions. Found that with the custom fuzzer. 3 years ago was a bug in fonts. Found that with so that regex fuzzer was an actual regex fuzzer that understood regexes. 3 years ago was a bit flipping fuzzer in fonts. 2 years ago was I think it was another bit. It was the same bit flipping fuzzer on fonts as well. That they just never bothered to run my fuzzer. I mean, that's the worst thing about that I gave my talk about fuzzing is now the companies have my fuzzer and they actually use my fuzzer, and so my fuzzer doesn't find anything anymore. and this year I won it for iPhone, and that was a bug in the way it renders PowerPoints. So there was the first time it wasn't totally a dumb fuzzer, so it was, I had to actually, so I did find bugs with a bit flipping fuzzer, but the bug I actually exploited was a bug that unpacked the PowerPoint a little bit and then fuzzed one of the data fields and repacked it. So it was a slightly small fuzzer.
Excellent.
And my SMS bug that I found was Sully, which is like, you know, Peach's little kid. Yeah, big boy.
We have a question for Jared. So Jared, given all your cloud work, what we found talking to systems is most of the cloud providers can't even spell security. Have you seen cloud providers using fuzzers to make their offerings more ready?
No, I haven't really had any experience with that. Like Charlie was saying, most of the work we've done has been in private cloud, so I haven't really played with public clouds that much at all, and I have no idea how they're trying to secure their stuff. I imagine it'd be more of like maybe trying to ensure that ESX or whatever they're using underneath is secure, rather than that, and maybe whatever communication. Maybe somebody else has a thought on that. I don't have a huge thought on that.
Well, we have this initiative called Code Labs, and we test different things, and Mikko here has been pushing me to test all those cloud and virtual setups, but let's see. I heard a rumor that someone crashed a cloud completely without tool, but I'm not sure if it's true. But I don't know. David might know any of them actually using our tools.
No.
No. Okay.
The worst thing for Jared and I for the public cloud is that our bugs are sitting on a public server. We don't want anyone to know our bugs.
Yeah, I mean, that's what
Yeah, speaking of rumors, there's a rumor that some of these public clouds would rather market away security than actually build it. But do you see a business opportunity? I know you guys are technical guys, but do you guys see a business opportunity in assessing how defensible various clouds are compared to each other? Like, for example, Rackspace costs X, and up the street Firehose costs 2X because they claim to have more security built in. So, do you see an opportunity to have a new addressable market?
Well, I think there's always an opportunity when software that was never designed to be a security boundary suddenly becomes your only security boundary. So yeah, I mean, I think that with cloud services blowing up, I mean, you know, we've seen this focus. It went from like, you know, Windows networking services, and then there was a firewall, and now it was browser, and now we've got these cool phones, and now it's virtualization services. I mean, you know, remember when VMware came out, there was a lot of people focusing some bugs on that, and when hypervisor bugs in that. So certainly when, you know, the only thing standing between you and every other company using the cloud service is this virtualization, right, that's going to be a huge target. I don't know that I see a huge business opportunity in pitting one company versus the other. I certainly think that, you know, with it expanding, there'll be more and more tools from the fuzzing standpoint that target, you know, those types of technologies. And hopefully the companies, I mean, I think the companies will be forced to take care of it. What's going to happen is, you know, the first one's going to get popped horribly, and all of a sudden everyone's going to have, you know, everyone's going to be able to spend the money on doing it.
All right, so we promised we'd give you a warning to ask questions. Some of you were brave enough to do so. Who else has a question for our esteemed panelists? Be brave. They bought you booze. Yes, you.
So how much did the open source and available fuzzers influence commercial fuzzers like yours, for example? Because I've seen that now you have like unlimited and you keep it going.
It was the other way around, because we were way earlier than the open source fuzzers. So we started in '96, and back then there wasn't really much in. When it was Peach is probably the oldest open source.
Let's see, 5-6 years.
Yeah,
So that's
we've been around 10 years, so commercial fuzzers probably kind of triggered the, I don't know if it actually influenced open source fuzzers.
I don't know, fuzzers have been around for a very long time.
Fuzzers have been around for a very long time.
I think there's, you know, I view it as, there's always what we call the leapfrogging effect, you know. Certainly from CodenomiCON standpoint, you know, they get to put like 30 devs to just dedicate to fuzzing. And that's going to get them to a certain point. You know, any organization or any company, to a certain point, it might stagnate or be too internal focused. And I think in the industry, you you always see that ideas go back and forth. There's always that one, Charlie Miller's come up with a new idea one year, I've got a new idea the next year, Jared's got a new idea the next year, CodenomiCON, suddenly gets in the game, they've got some new ideas over here and over here, and everyone just kind of feeds off each other, and I think it's wonderful. I think that, just the fact that, supposed competitors, all be sitting here, talking together, shows that we're really not competitors. I think everyone kind of views it as there's plenty of room out there, and we all build off each other. Every new idea that comes up only benefits our environment, especially as long as none of us are out there just creating patents. Hopefully, we'll just start doing that, and then we just all build off each other, and the users end up really benefiting.
Yeah, I never even heard of fuzzing until University of Ulu, destroyed ASN1, and that's when I was like, wow, fuzzing is pretty cool, and that was a huge influence in everything I've done. Is that was sort of for me the first. I know there were fuzzers before that, but that was the first thing that just destroyed all the commercial products, and so that was for me that was the eye-opening event.
So before we started doing, of course there was open source and free fuzzers, but all of those were random. So that was the trigger for us to actually start building model-based fuzzers, because it seemed like not the right way to do fuzzing, just randomly changing, even though people still are doing it successfully. But for the industry, especially in telecoms, the requirements actually were for model-based, where you actually get test case documentation and all that, because you are working with QA people, not with hackers, not with security experts, but mostly with testers and developers and people who look at products in a completely different way than security people.
All right, someone else straight back, yes.
Hi, Mike. I took your class last year.
Excellent.
But my question is to the whole panel. So, what kind of metrics can we use to actually measure the quality of fuzzing? So, basically, we can say, we need to run 1 million or 2 million iterations. We need to have high code coverage. But this seems like indirect. I'm going to quote Charlie using his book and presentations. If the code is executed, doesn't mean the code is well fuzzed. So, what kind of measurement we can use, to a certain point where we can say, okay, this module is reasonably fuzzed, and we can launch the file.
Well, that's a great question, man. I think we pretty much touched on what we've been seeing as the evolution of fuzzing methodologies over the last several years. Even if you just went back, 5 years, and you start talking about mutation-based fuzzing. The idea of doing mutation-based fuzzing is maybe I start with 100 files, 10 files, and there was a lot of thought on the line whether or not that was important. Now we know that template selection when you're doing mutating fuzzing is just massively huge important. So I think all that's evolving. In terms of the question of when you stop, I think Microsoft's SDL actually has a really brilliant approach. What they say is that if you're doing kind of the random fuzzing where you're continuously fuzzing, what you want to do is maybe you start, maybe if you're new to fuzzing, you start with say 150,000 is the number, and you want to fuzz until you have 150,000 clean iterations where you don't find any new bugs. And that's the thing that's really neat about that is it kind of self-scales to the quality of your target. If your target just has huge numbers of bugs, you might end up doing 10 or 20 million iterations. If your program is very simple and has few bugs, you might only do, say, a couple 100,000 iterations. It basically just kind of best fits. And then as your company progresses along the path, you can increase that number. Maybe the next year the number is 250,000. But I always kind of say that's a good number for shipping. In terms of fuzzing, even after you ship, just keep running it and see how things go. And of course, you can always use things like code coverage to see how far, how much of your code you're exercising with your data models and your use cases. But I think that's all really an emerging, developing system. We're always coming up with new ways to look at it and new metrics we can point to.
What's funny is Michael says that Microsoft's approach is really great, and I totally have the opposite. I think their approach is the stupidest approach you can imagine, because imagine a fuzzer that's the worst fuzzer you've ever written. It's going to run lots of clean iterations, but that doesn't mean you're done, right? And if you have the most brilliant, ingenious EF, fuzzer, maybe it only runs 5 iterations, it always finds a bug, so you never finish. And so I think putting a number as you need to run this number of iterations is just totally the to, do it based on, so what I recommended, which is like really hard to do, is you run it until you graph the number of bugs you find versus the amount of time you run your fuzzer. When that graph becomes sufficiently flat, you're done.
Isn't that kind of the same thing?
It's not, because yours has a number that says when you hit this number, you're done.
No, when you hit a plateau. Your plateau.
No, So yours is about.
It's about promoting a bad fuzzer. So
but the thing is,
worst fuzzer
if you have a bad
excels
fuzzer,
on yours.
if you have a bad fuzzer, you're always hitting a plateau of no bugs, right?
Well, every fuzzer has a plateau.
Right.
Definitely.
So, that's what kind of how I view the Microsoft ways, is you're trying to find that plateau in a way that's easy to explain.
I guess I just don't think that you've really found the plateau with that approach.
Okay.
No one fuzzer to bind them all.
Yeah. No one methodology binds them all yet.
And what you said is actually a great point. So it turns out that one fuzzer finds certain bugs, another fuzzer finds different bugs. And so, in fuzzing, everything's obvious basically. Like everything I've ever discovered about fuzzing is so obvious. The only thing that's not obvious is that different fuzzers find different bugs. And so make sure that when you're fuzzing something, you don't run like the coolest, super awesome fuzzer and then you find all the bugs. It turns out the stupid fuzzers find different bugs. So you need to run like 10 different fuzzers.
Yeah,
that's the only non-intuitive thing I've ever learned about fuzzing.
So Charlie, I work with lots of CISOs, and one of the large insurance companies in the U.S. said he looks at fuzzers like instruments in a symphony, and you cannot possibly play a symphony without multiple instruments. So I'm not sure if that's economically feasible, but it does support your idea that you need.
That's the only CISO I've ever heard say something smart.
Well, I also think that shows a great area of how immature, even after so many years, fuzzers really are. Is the fact that all these fuzzers, there's someone taking a very slightly different approach. Whether it's maybe I write my 6 lines of Python different than Charlie, and he's finding a whole different slew of bugs.
Right.
And I think that's another thing that we'll end up normalizing. I think the other thing we do, hopefully, as we write fuzzers, is when I go look at Charlie's talk, I'm like, oh, his 5 lines was different than mine. I'm going to go copy that and add that into my fuzzer. And then hopefully, as we progress, we'll have less and less of this divergence. Because honestly, going to a customer and saying, you need to run 20 fuzzers, that's really not acceptable, right? You really can't do that. So yeah.
So if I can add, different people use different type of fuzzers. So especially if we look at our tools used in like a product lifecycle, lots of the developers and testers like to use model-based tools because they look like testing tools, they get documentation and all that. But then somewhere you have a product security guy who likes to use mutation-based, like our traffic capture fuzzer, and then build lots of fuzzers very fast, test something in a matter of days and test everything quickly and do like a small test, base level test. And then some people just prefer file fuzzing or random fuzzing, or like our universal fuzzer is it like 25 different fuzzing techniques built into a product that can then be used by a different person in different use case. So, of course, there might be some superheroes somewhere who actually use all the possible fuzzers, but I don't expect that to happen in a product company. It's different people using different type of fuzzers, some of them in open source, some of them commercial, and everyone finds bugs, most likely.
So fuzzing is usually in the builder, breaker, and bridger kind of categories, or fixer categories. Fuzzing tends to fall into the breaker category. I don't know if you guys have seen this site, but offensivecountermeasures.com is trying to collect a bunch of free and open source scripts or utilities to try to do something more like active defense or even offensive measures. One of those such tools is called Web Labyrinth, and it's designed by someone who used to do web spidering on websites to basically make sure that he could never ever accomplish his normal attack methodology. So could I try to challenge this group of breakers and put it on its head and say, what kind of things could software developers do to instrument or crumple zone or attack awareness their implementations to make your job much, much harder? If you could flip it around to the defensive, what kind of ideas would you have to make it really difficult for your fuzzing techniques to work? Let's start with Jared.
Well, part of that, I guess, it depends on how you're viewing it. I tend to view things from the attacker standpoint. So general OS mitigations like ASLR and DEF have done a good job in terms of, like, taking away some of the impact of some of those bugs, at least partially, although the motivated attackers always find ROP and different ways around it, so I'm not sure if that's definitely not the answer. So OS mitigations are great, obviously from a defensive standpoint you need 4 of them, but you still got to get those bugs out. Because, if there's memory corruption, somebody will find a way to exploit it. So in terms of trying to, I guess just the things we've been talking about, trying to make sure that it's in the STL, people are using fuzzing. I don't know, I'll let somebody else take it away from there and talk about how to integrate.
Yeah, that's an interesting question. I mean, it kind of gets away from fuzzing a bit, but I think if you're thinking more like web-based attacks, when you're going over network and you own your own systems, I always tell developers, never accept bad data. And if you start getting a lot of bad data, you need to, you can write some defensive measures and not actually provide, cause serious DOSing attacks. If you see sustained, this is almost where I hate to say it, if you're on the web and you're getting attacked by a fuzzer, which seems like a strange occurrence, honestly, strange enough, an IDS might actually be interesting there, something that can, or a WAF, something that can say, hey, maybe I can selectively turn off access to this IP address, or at least throttle down their bandwidth access to the site to basically hamper their attacks, or do something else along those measures. I don't think that would really defeat, from a fuzzing standpoint, that wouldn't really be applicable. I don't really think we don't usually fuzz over the internet to websites, so I think it would be useful for attackers. But
and again, it's about how would you make your own job harder.
Yeah, for that it's.
Two things come to my mind about really making fuzzing challenging. One is it was kind of mentioned also, but I've seen a device that blocks, like you said, packets from a specific source after like a malicious attempt, and then suddenly your testing cycles become extremely fast when you have to wait for a period of time, or you have to reboot the device in between every single test case, or something like that. And I think the worst thing that I've seen in the past is a tradition of reliability engineering, or is it, I hope it's not part of the Rocket program, but exception handling, where you really handle memory exceptions, where you kind of corrupt your process slowly and slowly, but you don't let it crash. That's like the biggest challenge sometimes when you cannot instrument the actual process. You start overwriting memories and it becomes corrupt, your documents becomes corrupt, your files, your media, videos, you see weird effects on your camera and all that. That's a really dangerous sign, because when you don't have access to a debug build, or when you cannot really detect those failures, then you cannot find those bugs either.
And honestly, as I think about it, like actually trying to defeat fuzzing specifically, one doesn't seem like it's truly possible unless you have a sealed container that hosts your service you can't get into and turn those features off. But it also seems like all the things you might do to really cause harm, slow down the fuzzing, adds so much complexity to your program that it's probably almost self-defeating. And if I can get a copy of that program down locally and turn off, get around those, if that means I start finding more bugs than you found because your own tools of fuzzing stopped you from finding bugs, then that's going to be a pretty big problem too. Honestly, I look at companies, and it's funny because I do a lot of source code review, and one of the things I've seen a lot lately is you see the comment, added CRC to defeat fuzzing, which is kind of amusing and goes along the same thread, which I always thought was troublesome because, how hard is it for me to update a CRC? Not very hard. But what you may have done is you may have defeated your own security teams for fuzzer, and now I'm going to find all the good bugs. So honestly, I think, from a company standpoint, they should make it easier for themselves to fuzz at least, and just find the bugs. I mean, the best way to protect yourself is find the bugs, lock your systems down, use OSs that have things like SLR and DEB, and prevent the bugs that we do find from being exploitable.
You have to remember also that exploitable means different things for different people.
Absolutely.
For many people, exploitable is a crash. And security people doing fuzzing somewhere might find tens and tens of crashes, but they don't report those because they don't think they're security problems. But actually the end users, like in telecoms, would be extremely interested in getting those crash level issues out from the products as well.
big part is probably what you were talking about earlier with the monetary spending. You're talking about how little money is spent in the security industry. I mean, if you really want to make it harder for security researchers to find bugs, then you just hire all the security researchers, make your code better, and then those guys are either off the streets or their jobs just harder. I mean, that's part of it.
I thought Sony taught us you're supposed to sue them.
Or you can fire them.
So Charlie's strangely quiet. Either trying to dodge the question or.
No, I'm not trying to dodge it. So I've thought about this a lot actually. I wrote a whole paper, I just haven't published it. So some of the things I thought about were making analysis of crashes hard. So that's the thing I say is the most time consuming. So if you can make that even harder, then it's really exciting. So like you make things like the same input crashes it and it crashes in a different way somehow, right? Or maybe you make it to where you know, you can imagine every basic block is encrypted and decrypted right before you run it, and so that, you know, backtraces look bad, or that, you know, you can't analyze the, you know, code not locally, and so just things to make crashing processes hard to analyze. We make things harder. So it doesn't actually hurt the fuzzing, it hurts the analysis of crashes.
Seems like it's a cat and mouse game though. It seems like the second you do that, then someone writes a tool to deal with it, and it just goes through the cycle, right?
It's true, but it's, you know, anything you can do to make it harder is harder.
And the other question is, would that actually make it, like, who would that make it harder on? Because then if the company that's putting their stuff out in the field, they get these crappy crash reports back and try to fix their own bugs, like internally.
Well, I mean, they wouldn't be able to, but at least they could fuzz their own stuff without all that crap turned on.
That's true. They could,
how does that change the execution of the program?
So let's be democratic about this. Raise your hand if you'd like Charlie to actually publish this paper.
Sweet. So only one person's not doing it.
All right, let's do that again. Raise your hand if you'd like Charlie to publish that paper.
Come on.
All right, still.
To Charlie's point, I used to hate the idea that obfuscation is a valid security measure, but due to pressure of people keep asking about it, I make that show a part of my Java training.
Yeah, no, I mean, you know, it's not something you should rely on, but you know, security is like an onion. You need to have layers. You never have just have one layer. You know, everything you do that makes it a little bit harder to find something or do attack surface is easy. I mean, if you call your admin site admin.asp or ASPX or JSP, you know, I mean, if you just rename it to maybe a GUID or something else, I mean, like at least the automated, you know, scripty scanners not going to find it. And if you messed up and you have a simple bug in that, then it's at least a little hard to find.
So, yeah,
I'm not going to go tell someone to not do an audit and just start renaming all their pages, but you know, there's something to be said about every little layer you can do, adding to the total security of your system.
Well, this presentation kind of alludes to that, where you have you get different quadrants of the attacker. Right. You know, you have the really skilled guy, and you have the not so skilled person, but they're kind of chaotic. Whatever. You have the different
right, they're the low side or
And
on-site.
so if you have that little bit more bar to go over, so you got to read one more book.
No, it's, honestly, with the attackers, you know, you're looking for the, you know, if you're going to scan, you know, it's usually, you don't usually just pick a target. Usually you just, like the horse is loose, you scan all these websites, and the one that comes back with the easiest entry is the one that gets hacked.
Yeah.
And that's why if you look at like all the hacks that get reduced by some of these groups, you realize that, you know, sometimes it's some really weird office that got popped. It's because they're the ones that have the easy SQL injection bug. So if you can just get past that, you know, if you do just enough right and have a little enough attack surface, you're probably going to get passed over for the most part. Now, obviously, if you're like, you know, Microsoft.Live, you're going to have a lot of people just focused on you, but, you know, yeah, everything you can do, yeah, it helps.
I can't tell you how many times I went to fuzz something and like I couldn't attach a debugger to it easily or something. I was just like, it's not working.
Exactly, right?
Yeah, so any little thing, it's like, man, forget it.
That's true. So hackers are, the spirit of these true hackers is laziness, or as my friend likes to
It's
call
not
it,
lazy,
efficiency.
it's
Efficiency.
I can be more efficient.
If you're not paying me, I'm going to be efficient.
So lazy efficiency.
No, but if it did, I'd probably be like, that guy knows me, I'm not going after
If
him.
you look at the RSA security, no matter what you did, they were determined enough to undermine it. Yeah. If you look at most of the lulsec or anti-sec campaigns, incredibly low-hanging fruit, incredibly opportunistic, and although there are some very talented people in that crew, most of these are pretty amateur. So it's really convenience. It's not like they said we're going to attack the CIA and then did. It's that they tried to attack 15 people, got the CIA, and then said, oh look, we're going to attack the CIA. So there is a point of diminishing returns where a certain class of adversary will plateau if you've done enough security by obscurity. Even though we claim it's a religious myth, it works for certain classes of adversaries.
It's not something you should rely on.
It does not work for the RSA security type people.
Well, and who knows how they got into RSA, right?
Well,
You know, more likely they got in through some trivial little branch, perhaps, and just worked their way back.
In most cases, the first guy's job.
it's
Well, you
usually
get a
social,
job
it's
there,
usually
right?
social
Yeah.
engineering. You know that there's a great book called New School for Information Security. There's a blog, New School for Information Security blog. And the one chapter everyone remembers is called Chumps Study Crypto, Professionals Study Economics. Right? And I've tweaked it a little bit. Chumps study reverse engineering, professionals study social engineering. Because most of these lately, the really good ones are really wetware. It's really social engineering. It doesn't mean that what we're doing is not important. What it means is the really, it means Charlie versus Chump. No. What it really means is that class of determined, persistent adversary, which is a pretty small group, they're going to get in. But for the rest of them, you can...
All I can say is you're onto something. There's some meetings we've had with a bunch of different organizations and we talked about similar things.
Well, it's funny, like over the years of doing all this security consulting, we always ask, can you do the social engineering? And they always say no because we know you're going to succeed. Like it's just another factor, right? They know that's always going to be, it's not a solvable solution easily. Like, I mean, the few times we get to do it, you know, the easiest one is you go to the restaurant near the campus, you dig in the fishbowl of business cards, you grab one of them, you walk in the door and say, you're Joe from St. Louis, you need to get a badge, and you've got an office in 30 minutes. Like, it's really not that hard. I've seen people walk into the Pentagon and tailgate through security. You know, it's always, social engineering can always be an issue. And I think over the years, like, the reason that no one asked for it, for the most part, is because they don't know what they do. They know you're going to get through, and then what do? You know, they send everyone through security awareness training again. You know, that's really that's no solution. So I think the other side of that is I don't know that anyone's come up with, that I've ever seen, good solutions for the social engineering side of the world, and therefore everyone just assumes it's a major risk, or you know, they acknowledge it's there with a head nod and then ignore it.
So I'm going to tie this off on the fuzzing panel, because I could easily get us into social engineering easily.
Let's go.
So let's keep in mind the future and not just lament the past. For 60 seconds each, I'll start at the end with Ari and work backwards to Peach Fuzz. So last year, Ari very succinctly, and I remember this as well, he basically said the challenge last year was that fuzzing needed to focus on speed and performance of fuzzing. So for 2012, right, when we come back here next year, what should everyone in this room be looking at? What's the challenge and the opportunity for between now and 1 year from now? What should we be focusing and optimizing on? Is it the same thing, Ari, or what would you guys say?
I think the key requirement for future is to have a requirement for fuzzing. And that's the biggest challenge, because people don't know how to say what is good enough fuzzing, what is enough fuzzing, what kind of fuzzing needs to be done. But if you look at QA people, if you look at procurement people, you have to define some way to say what is enough of fuzzing and how you need to do that. So I think it's kind of more about the business side, not really about the technology side. How do you get even the small manufacturers to do at least some level of fuzzing, if not like the perfect possible fuzzing in the world. But now, without any requirements, without any way of even comparing two different fuzzers to each other, you don't have any metrics. You have no way of actually dictating that whether it's 100,000 test cases you need to run, or whether it's 2 weeks of testing you have to do, or how do you define what is the requirement in software development, what is the requirement in procurement?
So I'm going to summarize that as goal-oriented fuzzing. Charlie?
So, you know, if I did know what to do in fuzzing, I would tell you guys.
Security through obscurity.
Right.
I think you do.
Yeah. Well, maybe. So I would say, as an attacker, so I don't really care about your guys' products, and they're perfect. else. What I care about is finding bugs that people care about. And so for me, it means two things. Finding very important products or devices and protocols that have had stuff added to them recently, so there's new code that people haven't tested, but people care a lot about, or finding, you know, products and devices and protocols that are becoming important that no one has really looked at. And so as an attacker, I'm looking for, you know, I don't want to spend a year looking for bugs. I want to find a bug quick. And so those are the things I'm thinking about looking at this year.
So I will add and summarize that as prioritize or target selection.
I guess I'll, you know, summarize mine as pipeline. So just trying to create some sort of repeatable process where you put the binary in, the crashes come out, and those get sieved further down to the bugs, and out pops the exploit. So sort of like automated exploit development. Sort of following along what you're talking about, kind of more from the attacker standpoint, and I'll let you talk about defensive standpoint.
Yeah. No, I think methodology, you know, what Ari said is, I think that's a huge point. I think that, you know, as we get more and more adoption into corporations, you need to have methodology pretty well defined to help them be successful in their process, to know when to stop fuzzing. I think one of the things that we might start seeing is more of a push to get the customers to hand off their fuzzing to people who actually know what they're doing. And the field changes so fast and still needs certain types of technical personalities that, you know, for a lot of companies, you know, the bang for buck can really be handed to the masters and say, make this good, find the plateaus, whatever those plateaus are, and run the good stuff on it, and give me my bug output. I think that's one area that you know, needs to happen. And I also think tooling needs to really improve. You know, right now, you can see things like running code coverage utilities to select templates to fuzz from. I think are still in their infancies. You know, it seems like every time I have a spare day and I go look at my own tools for doing that, you know, I can get like a 20% increase in speed. You know, I can make it a little bit easier and convenient for the user to run. You know, things of that nature. And I think as a longer term, you know, I think there's a little bit of divergence between the embedded space and more of the OS space. I think feedback loops, you know, being able to provide more feedback as you're fuzzing into your fuzzer to continue finding new spaces that really improve technology-wise is another place we're going.
And
there's one thing that is missing. Because there you're only focusing on crashes or exploitable bugs, but you're not focusing on finding the bugs that you need to actually make your exploitation reliable. Okay, so you're looking for bugs that are going to give you EIP control, but not on the bugs that will allow you to read memory, to bypass ASLR, etc.
So Sergio is commenting on, you know, what type of bugs we're looking for. We need to change or improve that. And honestly, I think when it comes to fuzzing, there's really two camps. There's the people who care about writing an exploit, and the people who care about defense. And honestly, if you're on the defensive side, I don't care if Charlie says it's not exploitable. You probably want to fix it because, you know what, in 2 years, Charlie can probably exploit it in 1.0. You know, we move so fast in this world. You know, one of the ones I loved was when Matt Miller came up with exploiting the unexploitable, exploiting null pointer references. And all of a sudden, everyone's like, wait, you can exploit null pointer references? We've never fixed those bugs. So I think, you know, I think there's also a big shift in the fuzzing community between the people who are interested in writing bugs and maybe selling the bugs, and the people who are interested in more doing the full coverage, finding all the bugs, and, you know, maybe doing some risk analysis, but also, you know, realizing that any bug tomorrow almost can turn into an exploitable issue.
I think that field's actually diverging too. It used to be
Yeah,
the
no,
skill set was very similar, like between the offensive and defensive bug hunters, but it's like now, you know, just sitting through a ROP class, like, I mean, who has like studied ROP? It's like the stack pointer is the new instruction pointer, and you have to come up with all these widgets to do that. There's crazy stuff you got to do to actually write exploits now. So you're seeing, to your point, a divergence instead of a convergence of skill sets, which is odd. I don't think people really saw that one coming.
No, I think it's a natural thing. I mean, you know, the defensive person, I think if they look ahead, they really want to be able to analyze the bugs faster or find the bugs that are more easy to exploit faster. Now, the defensive side, we really want to find more bugs faster and cheaper. You know, on the defensive side, it's never been about that one bug in the easy target. It's always about finding every bug. So hopefully, when Charlie does pick you up, he decides you aren't the easy target or doesn't find the one bug, or you don't show up in his top 10 list of Black Hat. So there is, I think, a massive divergence going on to a certain extent in the field over that.
All right, I'm getting the signal to wrap up, so I'm going to, I think a common thread between all these forward suggestions, and it aligns well with what I said at the beginning here. Most people in IT security either do it because they want to make a difference, or they want to make money, or both. So for anyone in here who wants to make a difference or want to make money, I would suggest that prioritization, workflow, sort of risk analysis, any way in which we can make business people care about this more is what's going to turn this from a very, very small addressable market with very, very few people caring about our impact to a much larger one. So I challenge us that by this time next year, we found some way to make this relevant to business people as well for our impact and our financial benefit. So I would like to thank my panelists and thank the audience for sticking through this and having some food, and turn it over to our MC. Thank you.